Now we are in the second video on computation of standard deviation. In the previous lecture, we have seen how to compute standard deviation for an ungrouped data. Do you remember what is standard deviation? From the mean score, to what extent each and every score lies, the average is considered as standard deviation. Let me come to the equation. Before that, let us define standard deviation once again. Yes, as the best measure of dispersion, standard deviation is defined as the square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. It is very clear. How do we mention it? Square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. For a non-group data, standard deviation, that is, we simplify through this as square root of x minus x bar the whole square by n. This was the equation we have mentioned, that is square root of arithmetic mean of, I'm sorry, I just forgot sigma. Let me write the equation for standard deviation. The simple is mentioned like this. For an ungrouped data, what we have mentioned? Square root of arithmetic mean of squares of deviations of observations from their arithmetic mean. This is the equation for calculating standard deviation for an ungrouped data. Now the concern is, what is actually standard deviation? How do we mention some aspects of standard deviation through a picture? See, if your scores are all in a single line, of course your normal curve will be somewhat differ. This curve is what kind of curve it is? Have you learned about kurtosis? Kurtosis. Based on the kurtosis, that is height of the curve. What kind of curve it is? It is leptokurtic. It is leptokurtic curve. If your distribution is leptokurtic, then standard deviation score will be very small because most of the scores are in the same area, same region, central region. Okay. If it is platykurtic, this is less than, sometimes normal curve or less than normal curve. Here there is a wide spread of the score. So standard deviation will be larger. For the normal curve, standard deviation will be bigger than the leptokurtic. Again, it will be bigger than normal curve if the case is a platykurtic curve. Platykurtic curve will be more flat than a normal curve. This kind of curves, this is platykurtic, right? Platykurtic curve, and normal curve is mesokurtic curve. Just for the information, I have mentioned all these. Now let us come to the computation of standard deviation for a group data. So how to calculate? See the equation. So earlier what we have mentioned in the equation, the same equation along with we are adding f. F also we are adding. Like for the mean, what we have done? For an ungrouped data, x bar or mean. What is mean for an ungrouped data? Sigma x by n, right? For a group data, what is mean? It is sigma fx by n, right? We added x. Same way we added f. Same way we have to add f in the equation of standard deviation to make it an equation for a group data. So what was for ungrouped data? Standard deviation. Square root of sigma of x minus x bar the whole square by n. Yes. Now is square root of sigma of f into x minus x bar the whole square upon n. Only f is added. Just like what we have done in the case of arithmetic mean, we are adding frequency f, that is for frequency. Got a clarity? See the equation, read the equation very specifically. Square root of sigma of f into x minus x bar the whole square upon n. Got the clarity of equation? Yeah. Now let us come to the calculation of standard deviation. For a group data, we are calculating standard deviation. See, I've mentioned all the terms that we have to identify. Don't confuse. I have used instead of AM, I have used mu, arithmetic mean, represented arithmetic mean, mu, right? X minus x bar, all these things I have mentioned. What is the status of a group data? How do we mention this as a group data? Yes, since it is a frequency distribution, classes and frequencies are given. This is called as a group distribution. This is a group distribution, right? This is a group data, group distribution. Now, for a group distribution, initially what we have to do, for any distribution, whether grouped or ungrouped, for standard deviation, we need to identify the arithmetic mean first. Shall we go? What is the equation for arithmetic mean? Yes, it is sigma fx by n. Arithmetic mean x bar or mu is sigma fx by n. F is given. This is f, frequency. F is given. What is next you need? X. What is x in arithmetic mean? Yes. Do you remember? How did we calculate arithmetic mean? Yes. We went for this equation fx by n, sigma of fx by n. F is very clear, but x is not clear. What is x? X is the representation of the class, or we mention it as midpoint, right? It is midpoint. Got it? Midpoint. So shall we write the midpoints? Yes. 0 and 10. What is the midpoint? 5 is the mid x. 5 is the mid value. 10 and 20. 15 is the midpoint. 20 and 30. What is the midpoint? 25. Right? What is the midpoint for 30 and 40? 35. Right? You got it. What is n? We have to identify n also. What is n? N is total of the frequency. We will get n here. What is n? 2 plus 5, 7, 7 plus 8, 15, 15 plus 5, 20. N is 20. Now we got f and we got x. F is already given, x we have identified from the classes. It is midpoint. Now, terminology we need is fx. Fx. So I have mentioned fx as next column. F into x is fx. 2 into 5, 10. 15 into 5, 75, right? 25 into 8, 200, right? 35 into 5, 175. Am I right? 175. Let us go for a total. Then we will get sigma fx. What we are doing? Calculating the arithmetic mean to facilitate the standard deviation and its computation. Sigma fx by n. So sigma fx, we will get sigma fx here. Just go for that. 5 plus 5, 10. Reminder 1, 2, 7, 9. 9 plus 7, 16. 6. I put 6. 1 again reminder. 1 plus 1, 2. 2 plus 2, 4. 460. Is it correct? Yes, 260. 460. Alright. You can also calculate whether I am wrong or not. Yes. See, 460 I got. Now what I have to do? I have to go for computing the arithmetic mean. What it is? Arithmetic mean for a group data? Sigma fx by n. Sigma fx we got, n we got. What is sigma fx? Yes, 460 divided by 20. What is the answer? 46 by 2, 23. 23 is the mean of this group. Arithmetic mean of the group is 23. So you got mean, that is x bar or mu is 23. Now what is the next calculation for us? See, what is the next? This is the next. I'm just removing, otherwise it will be confused. So we got 23 as arithmetic mean. We have x already here. Now x minus x bar, x minus mu, that is x minus arithmetic mean. What is arithmetic mean? 23. What is x for first class? What is x for the first class? It is 5. 5 minus 23. What is 5 minus 23? Minus 18. 5 minus 23 minus 18. What is next? What is next? 15, right? 15 minus 23. 15 minus 23. Minus 8. Am I right? Minus 8. What is next? 25 minus 23. 25 minus 23. This is x. This is x bar 23. 25 minus 23. It is 2. What is next? 35 minus 23. It is 35 minus 23. 12. Got it? So see what we have done? X minus x bar. What is the square of 18? Let me check. 18 into 18. Yes, what is it? 4, 2, 324, right? I was having confusion, so I just calculate. 324, right? 324. 18 minus 18 into minus 18. This is 64. Square of 2, 4. Square of 12, 144. Right? You got the squares of all the observations. Squares of all the x minus x bar. So in the next stage, we had to calculate x minus x bar the whole square. X minus x bar, we got it here, minus 18, so we got 324. Minus 8, 64. 2, 4, 12, 144. It's very clear. Now, next what we have to do is, we have to multiply this value, that is x minus x bar the whole square, with f. Better to see the equation. This is the equation. Let me write the equation again for your clarity. I am writing it again by removing the previous calculations of arithmetic mean. Just let me write it. It is standard deviation is square root of sigma of f into x minus x bar the whole square divided by n. It is clear? Is it clear? Yes. Let me remove it right again for clarity. It's clear now, right? This is the equation. Now what is needed? X minus x bar the whole square is done. The next x minus x bar the whole square is done. Now we have to multiply this value with f. Then only we will get f into x minus x bar the whole square. F into x minus x bar the whole square. F is here and x minus x bar the whole square is here. When you multiply both these columns, you will get f into x minus x bar the whole square. What do you have to do? 2. 2 into 324. 648, right? 648. I got it. It's very simple because 2. 64 into 5. 5 into 4. 64 into 5 we have to go for 64 into 5, right? 320, right? 320. Next is 8 into 4, 32. Am I right? 8 into 4, 32. Next is 5 into 144. 144 into 5. You can go for 144 into 5. 720, right? 720. So I got the values 648, 320, 32 and 720. Here I'll get the value. What is the value? This value sigma of f into x minus x bar the whole square. The complete value that is given in as numerator inside the square root we will get here. Simply add it. So we have 8 plus 2, 10, 0, 1, 5, 5 plus 2, 7, 7 plus 3, 10, 10 plus 2, 12, 1, 1 plus 6, 7, 7 plus 3, 10, 10 plus 7, 17, 1720. 1720 I got a value. 648, 320, 32 and 720. Let me check it again. 8 plus 2, 10, 3, 3 plus 3, 6, 6 plus 6, 12, 1 again, 1, 7, 8, 8 plus 3, 11, yes, 1720, 1720. Got the value of the numerator. What is denominator? N. Is it clear? N? Yes, N is here. N is the total of frequency. As you know, N is the total of frequency. So, what we can do is, let me take the stage of calculation. Standard deviation is square root of 720. Let us go to the calculation. Standard deviation is square root of 1720 divided by 20. So the value, it is 86. Square root of 86. Find out what is the value of square root of 86. It's your turn now. Is it complicated? Not at all. It is very simple. Let me do it again for you. Let me explain again for you. Then it will be very clear. Let me rub everything. What we have done. I'm not going to calculate everything, but I'll give you a clarity what we have to do as a part of each stage. For clarity, I'm just removing some of the messy items, but I'll keep all the values here. What we have done, see, very carefully listen. We have a frequency distribution, we have frequencies. What we have to do? We have to identify the arithmetic mean of this frequency distribution. What is arithmetic mean? Yes, arithmetic mean is x bar is sigma fx by n. Sigma fx by n. So we have to identify the x that is midpoint. Then only we will get fx. So f is frequency, x is midpoint, fx. First case, I got 10, 5 into 15, 75, 8 into 25, 200, 5 into 35, 175. I got sigma fx here. This is sigma fx. I took this value and divided it with 20. Then I got the value of arithmetic mean. It was 23. You know that. It was 23. Altogether, we got the value 23 as arithmetic mean value. Got it clear? Now the next is the original calculation of standard deviation. Now we have calculated arithmetic mean. What is the calculation of standard deviation? What we require? Arithmetic mean and its deviation from the respective cases. So the case is represented with the midpoint. So midpoint, that is x minus arithmetic mean. X is 5, 5 minus 23, 18. Simple is minus. 15 minus 23 minus 8. 25 minus 23, 2. 35 minus 23, 12. You got the value x minus x bar. Now next again we have to calculate x minus x bar the whole square. I hope that you have clarity. See the equation once again. Standard deviation is square root of sigma of f into x minus x bar the whole square upon n. Okay. So x minus x bar the whole square we have to calculate. We have to calculate x minus x bar the whole square. Calculated the square of this value x minus x bar value square. So we got all the positive values now since we have calculated square. Now next is the same value of x minus x bar the whole square has to be multiplied with f, that is corresponding frequency. That is the term here, this term, right? The term, right? You got the term. Then only we will get this. So we have gone for this specific case. F into x minus x bar the whole square. That is, this column is to be multiplied with frequency. So I got 648 for the first class, 320 for the second class, 32 for the third class, and 720 for the fourth class. So once you take all the values together, you will get the complete value of numerator inside the square root. It was 1720 in the previous calculations you have seen. So the value you will get, then you will go for square root, whatever value you are getting, divided by total of frequency, that is n. Okay, n is 20. So you'll get a value that is standard deviation. I'm sure that you got a clarity now. Am I right? Yes. Now see. This is a standard deviation calculation as an example for you. You have to do this and post your answers in the discussion forum of the week. I hope that you can do that. This is for clarity. For the statistical clarity, you need to practice it. Whether it is online, massive open online course, or it is physical, doesn't matter. Practice matters. So once you practice this, definitely you will get it. Frequency and classes. So what is next we need? Yes, x midpoint we need. As next column we need midpoint. Next is frequency into midpoint. Then we will get sigma fx here. We will go for sigma fx by n, right? Next is x minus x bar. Next is x minus x bar the whole square. Another is x minus x bar the whole square into f, right? These are the calculations you have to do. When you get the total of this, divide it with number, and go for a square root of the value that you got. Are you clear? Yes, it is very simple. It's very significant. This is very simple. It is very significant as standard deviation is used for further calculations. You have to learn it properly. Practice how to do this. Practice it. Now I am with this slide. All of you write the stages in the copy when you watch it. Just memorize what are the stages that we have to do for calculating standard deviation. The frame of the table you just keep in mind. Definitely you will not forget it. This is the way of better learning. Now at the end, have you achieved the learning outcome? So my concern of learning outcome of this video lecture was equip the learners of this massive open online course to compute standard deviation for a group data, that is frequency distribution. Clarify the students and learners with the equation of computing the standard deviation for the frequency distribution. Am I successful? It's up to you whether you can do that. You can compute standard deviation. Yes. If you are able to compute, I'm also satisfied. If it is not, of course, it is not my fault. Most probably, it will be because of lack of attention. Watch again. Watch again. Definitely, you will get a clarity. It is not at all difficult. I can rate it as a simple calculation, not a complex calculation. Only thing is that step by step learning is the need of the standard deviation calculation. Step by step learning. Have a mental picture of what I have to do. Let us have a happy learning. Thank you so much for watching the video.